Everyone, this is a problem from the 1998 CMC Gauss 7th grade level. Thought it was kind of an interesting one. So it starts out with, on a large piece of paper, Dana creates a rectangular spiral by drawing line segments of lengths in centimeters of 1, 1, 2, 2, 3, 3, 4, 4, as shown. Dana's pen runs out of ink after the total of all the lengths he has drawn is 3,000 centimeters. What is the length of the longest line segment that Dana draws? Okay, so you get kind of clued in that we're dealing with arithmetic series just by the name of the person, Gauss. I think Carl Gauss was the person who came up with the formula for an arithmetic series. Basically, let's draw out a little of what it looks like. So we'll draw this first. So this side would be 1, that would be 1, this would be 2 across here, 2 across here, then we have 3 here, 3 here, and then this pattern just keeps going on and on and on until we draw for 3,000 centimeters. So the first thing I would do in this problem is I would factor out and simplify the series, because we just have doubles of everything. So we can do something like 2 times 1 plus 2 plus 3 plus ... plus n. Because 1 plus 1 is 2, 2 plus 2 is 4, and it's basically we just doubled what we had before. Now, the thing that Carl Gauss had derived was basically he had said the sequence, or the sum is equal to, if it's equal to 1 plus 2 plus 3, plus, we'll say n minus 1, and then we'll say plus n. And then we can find a formula for this by just rearranging this. We can say s is also equal to n plus n minus 1, because I'm basically just bringing this term down to there and this to here, and I'm just rearranging it. And then we can do plus ... then we have the plus 3 plus 2 plus 1. And so basically what we can see from that is if we add both of these together, we'll get 2s is equal to we'll add n and 1 together, which gets us n plus 1, and then we'll add n minus 1 to 2, and that also gives us n plus 1. So we can group these plus n plus 1, and it turns out we do this n number of times because there's n numbers in our series. So basically, this turns out to be 2s is equal to n times n plus 1. We can solve for s by dividing 2 from both sides, and we get s is equal to n times n plus 1 over 2. And then, since we found this earlier, we can just substitute what we derived from Carl Gauss's arithmetic series into this equation. So basically, we'll get 2 times n over n plus 1 divided by 2, and the 2 and the 2's cancel because it's in the denominator, and now we have n times n plus 1. And what is it that we are comparing? We need the 3,000 that we had before because they said only 3,000, and is it less than, greater than, or equal to? Well, it's actually less than or equal to. Let me explain why. Let's say we have, this is the very end. We go from here to here, and then it ends off with just a little bit here. This would go past 3,000, but then n doesn't count since it isn't this whole complete thing. It would get to just this small little section there. We want to include it before it gets to that small section, so we have to have it up to here, right here. That's our cutoff point. That's where it's less than or equal to 3,000. So then we can solve this equation. And basically the easiest thing you could do here is you can either use a graph calculator, you could use the quadratic formula, or you can kind of just put in guesses. A good guess here would be maybe like 50 is around a good guess. Or maybe let's choose one of the answer choices. Let's choose 50 first. Let's see what that does. So it's 50 times 51. What does that get us? Well, 50 times 50 is 2,500, and then if we just have another 50, this would get us 2,550. That is still quite far off. Let's see, we need a bigger value now. Let's try 54. Let's see if 54 works. So 54 times 55, we'll just multiply it this way. Well, 5 times 4 is 20. 5 times 5 is 25, so we get 27 here. We'll put in a 0 here, and then we get 20 again, so we'll keep that 2 up there, and 5 times 5 is 25, and then we get 27. So this actually gives us 2970. So that is just close to the cutoff point, and let's see if there's a bigger number that works. So I guess the next logical number would be 55. So 54 is a possible answer right now. 50 definitely doesn't work. 39 doesn't work. 38 doesn't work. And 55 will likely not work. Let's see. Let's see if it works. 55 times 56 is 6 times 5 is 30. 6 times 5 is 30. Plus 3 is 330. Plus 5 times 5 times 5 is 25, so we can just put a 2 there, and then 5 times 5 again is 25, and then this ends with 27. If we add that together, that clearly will get us over 3,000. So then 54 must be our answer then. So we can circle this, and then we would move on. Thank you for watching. Bye.